All right, now let's go to question 4. Question 4 says, what is the value of f of 1? And they give us a function where the function is defined on the domain 1, 2, and 3. So no other x values matters but 1, 2, and 3. So what is f of 1? We plug in 1 to get what is f of 1. So we plug in 1, replace x with 1 to get f of 1 is equal to a half times 1 minus 3. A half times 1 minus 3. A half times 1 minus 3 is a half minus 3, and a half minus 3 is negative 5 over 2. Negative 5 over 2. I'm just going to check that just to confirm. A half minus 3, yeah, that's negative 5 over 2. Nice and easy. Nice. Now, it says find the value of x for which f of x is negative 2. So we're going to set f of x being equal to negative 2. So we have a half x minus 3, half x minus 3, and that is equal to negative 2. Half x minus 3 is equal to negative 2. So bring over the negative 3 to get positive 3. And so we have a half x. We bring over the 3 to get 3 minus 2 is 1. So we have a half x equal 1. We multiply through by 2 to get x must be equal to 2. So that is it. X equal 2 to make f of x be minus 2. You can always check it back. Plug in 2 up here and you get, let me see, we bring over the 3, just checking again, bring over the 3, minus 2 plus 3 is 1, so a half x is 1, and so x must be 2. Put in x as 2 here, put in x as 2, we get 0.5 times 2 minus 3 is negative 2, so right, x is 2. Just to check back the answer right there. Now it says an ordered pair for the function is expressed in the form AB. It says using your answer in AI and AII or otherwise list the ordered pairs of F. So listing the ordered pair of F, remember the domain that we have is for 1, 2, and 3. So the ordered pairs that we're going to have, so let me zoom out just a little bit. The ordered pairs that we're going to have is, first we say that we have negative, we have 1. When x is 1, it's mapped to negative 2.5. All right, then we see 2. When x is 2, 2 is mapped to negative 2. Then the last ordered pair we have is when x is 3, what are we going to get? When x is 3, plug in 3 for x in the function right here, and a half of 3 minus 3. So 0.5 times 3 minus 3, we get negative 1.5. Negative 1.5. And so that is what we get, which is no issues. No issues at all. All right, that is what we get. Lovely. All right, so we'll finish this question. Or we'll finish the first part of the question. Let's continue. It says, explain why f of x cannot equal 5. Now, f of x cannot equal 5. Let's see why. Let's solve f of x equal 5 and see what happens. Why it can't equal 5? If we're solving f of x equal 5, we're solving a half x. We're solving a half x minus 3 equal 5. So if we add 3 to both sides, we're getting a half x. A half x we can write as x over 2 is equal to, add 3 to both sides, that's 8. And so multiply through by 2, we're getting x equals 16. But if x equals 16, 16 is not in the domain. 16 is not in set A. That's why it cannot be equal. F of x can't equal 5 because 16 is not in the domain. That's the reason. 16 is not in the domain of F. That's it. 16 can't in the domain of F because them don't tell you the domain of F is 1, 2, and 3. All right, nice and easy. Now it says solve the following inequalities. So to solve the following inequalities, very easy. 3x minus 1 is less than 11. So add 1 to both sides to say 3x is less than 12. Now if 3x is less than 12, we can divide both sides by 3 to get x is less than 12 over 3. And 12 over 3, as we know it, is equal to 4. So the reality is x is less than 4. Nice and easy. That takes care of part A. Now let's look at this one. It tells us that 2 is less than or equal to 3x minus 1. So 2 is less than 3x minus 1. So we can add 1 to both sides to say that 3 is less than 3x, and then we can divide both sides by 3 to say 1 is less than x. All right, so that is, we can put it this way, x is greater than or equal to 1. Now, of course, I didn't put the equal to here, so I'm going to put it on now. I left off the less than or equal to, less than or equal to, less than or equal to, x is greater than or equal to 1. Then finally, it says represent the solution of 3x minus 1 less than 11, but greater than or equal to 2. So as we can see for the solution is x is greater than or equal to 1, but x must be less than 4. So the two key areas I wanted to look at, guys, is from this, x being less than 4. X being less than 4, put a circle here, and you start pointing your arrow this way. Then right here, so now x is greater than or equal to 1. So you draw a circle from 1 here, so, and you shade it, because it's the or equal to. All right, they draw your arrow this way. Now, if it go from here, so, but have to stop here, so, then that means that the solution just be between 1 and 4. So the solution is between 1 and 4. X is between 1 and 4, where 1 is included in the answer. So that is it. That's how you represent it on the number line. Nice and easy. All right, soft.